Hello, thank you everyone for joining our webinar. Today's session will take approximately 1 hour. If you have any questions during the presentation, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. You will be able to see questions from other attendees, so please upvote or like the questions that interest you. This will help us determine which questions to address live at the end of the session. Please watch for an email tomorrow with further information and a link to the recorded presentation. And now I'd like to introduce our presenters, Michael Clem and Bronis de Sapinski.
Hello, everyone. I'm Michael Clem. I'm the Chief Executive Officer of the OpenMP Architecture Review Board. And I have with me Bronis, who's going to introduce himself now.
Hello, good morning, good afternoon, good evening, or whatever it is, wherever you are. I'm Bronis de Sapinski. I'm the chair of the OpenMP Language Committee, and it's a pleasure to have this opportunity to tell you about what's going on in the Language Committee. I'm also the general chair for SC21, so I just not going to talk about that other than I just want to say that I hope that most of you will be able to join me there in November in St. Louis.
All right, thank you. So let me quickly start off by introducing the OpenMP Architecture Review Board. So we are the standards body behind the OpenMP API, so the application programming interface. And our mission is to standardize OpenMP as a directive-based language that supports multiple base languages. So in this case, C, C++, and Fortran. And that provides to our users and programmers high-level parallelism that we do hope is performant, so gives the best possible performance for your application code, that is productive, so makes parallelism in the application code as accessible as possible, and portable, so that you can move between systems of different vendors, different software stacks, OpenMP implementations, and be portable. The thing that is important to note here is that the OpenMP API moves common approaches of the domain that we're looking at, so HPC and other parallel domains, into an industry standard. We are not conducting bleeding edge and standardizing that. We are basically taking the approaches that the community already takes and move them into a standard to make them, as I already said, portable. On the right-hand side, you already get a glimpse of the members that we have in our Architecture Review Board. We will come back to that in more detail after we've covered some of the technical aspects. The OpenMP ARB has a specific roadmap. We are on a 5-year cadence for major releases, and Bronis was going to share more about this cadence and the release process that we're having now.
Yeah, so first of all, not too long ago, I took a look at this, and I've been the chair of the language committee since 2009, so about 12 years now. But it turns out when I looked at it more closely, we've actually, since the beginning of the history of OpenMP, really managed, have maintained this 5-year cadence of every 5 years coming out with a new major version of the specification. And so in November of 2018, we came out with OpenMP 5.0. Down, Michael. Click.
Yes.
Maybe it's just taking a while. There. And just last November, we came out. So we do in general, we do one minor release in between the major releases. So, and typically we target 2 years after the major release, with the idea being that gives us time to assess where we might make important but minor enhancements to the major release, and also identify any errors and the such. So last November, we came out with OpenMP 5.1. In this 5-year cycle, we're actually adding a second minor release, and that will be OpenMP 5.2. I'll tell you more about that in a little while, but the intent is for that to be available in November of 21. And so, in fact, we'll be releasing it in time for SC21. The next major version will be OpenMP 6.0, and we'll also tell you more about what we're thinking about for 6.0 later in the talk. Typically, we would come out with at least one TR in between. So we had a TR, so I guess we want to click down again. Yeah, TR 8 in November of 19. We then had TR 9. So usually what we do is we release a comment draft that gives people an opportunity. We have a feature freeze and release a comment draft, and after that, we're only going to just look to find errors in what we've in the draft for the release, whether it's a major release or a minor release. We're actually pretty far along in the 5.2 process and expect to have the feature freeze following a week-long meeting of the language committee that we'll have at the end of this month. So sometime next month, we should be releasing TR10, which will be the comment draft for 5.2. And then the intent will be to release TR11 in November of 22, which will be a the main preview of what we're going to do in 6.0, and then release another TR that's the final comment draft in the July or August timeframe of 2023. And we expect to keep going on this cycle well beyond 2023. All right, so in developing the spec, this is our process. We've refined it a lot over the years. I don't want to bore you too much with it, but basically what happens is somebody says, "Oh, I think it would be really good if you added this to the specification, whether it's a new feature or an enhancement to an existing feature, or even just a clarification or correction to what's already there." We then implement that in LaTeX, discuss it, and following discussion, we hold a first vote on it and then a second vote on it, at which point the change is passed, and we have a final verification process to make sure there's no errors in it, and then we merge it into the main branch of the specification, all of which is actually managed in a private repo on GitHub. All right. So next, here's how the actual release process goes. So, and I kind of hinted at this already. Through this process of having proposals and voting them in and merging them into the main branch on GitHub, we develop a draft. We continue editing that and eventually release a comment draft. All right. At which point we go into a quality control phase. We take feedback from the community at that point. We actually accept feedback throughout, but the intent of releasing the comment draft is to formally give the community one last opportunity to comment on what we're planning to adopt. But in addition, the committee spends a significant amount of effort reviewing every page of the document and making sure that to the greatest extent possible that we catch any errors, whether they're grammatical errors, typos, wording errors, or something more significant where it's like we realize that there's inconsistency between different proposals that we've adopted or something like that. Hopefully we catch those in the verification process of the individual proposals, but just to be sure nothing major is wrong with it, we go through this quality control process, have a final draft that is basically the end product of the language committee process, at which point the draft is delivered to the ARB for approval and formal adoption, and release is the next official version. All right. And now I'll hand it back to Michael.
All right, thank you. So just as a recap to prepare the stage for OpenMP 5.2 and what we're planning for OpenMP 6, I want to quickly build up a slide that shows what we did with OpenMP 5.0. And from the list that is building up now, you can pretty much see that OpenMP 5 probably is the biggest release that we ever made since OpenMP was created in '97. And we can't really go through all of those details. The thing I want to mention here is that we are certainly planning on having future webinars on select topics that I'm showing here. The other thing that I would like to say is that there is a constant stream of webinars from other community members as well on these topics. And let me just highlight a few features that we introduced. So one notable thing that we did is we moved the base language support to be latest C++ 14 and 17 support for OpenMP 5. Remember, that is like 3 years ago already. We also moved Fortran support up to 2008. In terms of GPU programming, we introduced support for unified shared memory. So GPUs that share or can natively access host memory without data copies. We introduced the collapsing of non-rectangular loops. So if you have an algorithm that you want to parallelize that has a triangular loop nest, one particular example is the back substitution in a linear solver. You can now collapse those non-rectangular loops and then use work sharing constructs on top of that collapsing to parallelize those loops. We introduced meta directives, so we can now do meta programming in OpenMP where you can test for certain capabilities of the implementation and then specialize your OpenMP directives according to those conditions. We introduced parallel scan where you can parallelize loops that implement parallel scan prefix and postfix. We introduced the loop construct to move OpenMP a little more into the domain of descriptive languages. We introduced affinity support for both OpenMP threads, but also OpenMP tasks. And we also recognized the trend in the industry to have a deeper and more complex memory hierarchy. And so we now have support for memory allocators in OpenMP. And then on top of that, OpenMP 5.1 went ahead and refined several of those features and make them more useful and more succinct. And on top of that refinement, we also introduced new directives. So for instance, the loop transformation directive, where you can now talk about tiling and unrolling. We added C++20 support. We actually prefetched C++20 support before ISO C++, the working group, actually released the standard. And for the C++ programmers, the probably most notable difference in OpenMP 5.1 is that we now support C++ attribute syntax. So if you have a C++ compiler with OpenMP support, you can now specify directives in the syntax of C++ attributes, and you don't have to use pragmas anymore. All right, and now, Bronis, we're going to talk about OpenMP 5.2.
Before before we go on to that, let me just go back to 5.1 for just a second. So I think Michael was correct that the attribute syntax is probably the most significant addition, although for now it is largely syntactic sugar for the existing syntax, for the existing features. Some of the other features in there that are also fairly significant, the assume directive is one that I think will prove very useful for allowing compilers to implement much more efficient code. And I've gotten feedback from Livermore users. I work at Lawrence Livermore National Lab. I guess I didn't mention that earlier. The error directive is also one that they mentioned as being particularly important. It's a small feature, but it can be very useful. All right, so OpenMP 5.2, what's it going to be? Well, so the attribute syntax actually motivated us to decide to do 5.2, and the way we adopted the attribute syntax in 5.1 was basically, we said what the mechanism was, we defined how it works, but we didn't update all of the syntax boxes throughout the specification to reflect that there's attribute syntax. Instead, we just said, oh, you can also use attributes. And we made some other small changes to make it so that it would be more consistent with the way attributes work in C++. But there were some other things that basically we felt could be stated more clearly and would support us being able to, in 6.0 and in the future, better able to exploit the benefits that having attribute syntax could provide. So we decided to basically redo how we specified the syntax in OpenMP. And as part of looking at that, we realized that we often had inconsistencies between what we specify for different directives and clauses. We often hid restrictions in the syntax box. Basically, like, well, here's a clause. It has a modifier, but oh, we didn't list the modifier in the syntax box for that directive, and so therefore you can't use that modifier. Sometimes that was intentional, and sometimes it was more than likely an artifact of we adopted a directive at the same time we were enhancing the way the clause worked, and so the directive got the syntax of the old clause syntax, and the new clause syntax didn't make it into the directive. So basically, we're completely we're specifying the syntax at a much higher level, so that now you can basically say, well, here's a directive name, and here's the way it works. You always, if it can adorn this type of base language code, and clauses look like this on any directive, all right? And so that way, the clauses are now specified fully separately from the actual directives. All that's specified with the directives is that you can use that clause on that directive. So now, if there are restrictions on what you can use on on some aspects of the clauses related to that directive, they have to be explicitly stated in the restrictions on the directive. All right. Another thing is that we sometimes thought we were being clever and adopted overloading of clause names or things like that. And we found that it made parsing for OpenMP much more complex, but it also could lead to issues where we needed to have a lot more restrictions on the use of the clauses. So we're actually deprecating a lot of the overloading of clause syntax, or even in one case of directive syntax. So for directives, we have an allocate directive that is normally a declarative directive, but can also adorn and annotate a Fortran allocate statement. And the way that allocate construct works was unusual in itself, and actually, because we needed to be able to disambiguate the allocate construct from it being a declarative directive, it then brought in restrictions on where you could place it that weren't very useful. So we're going to change that to the allocators directive. The allocate directive will still be available. I mean, the allocate construct will still be available in 5.2, but we'll be removing it in 6.0. So what are some of the other things that we've deprecated? Well, one thing that we deprecated that wasn't because of syntax issues was the minus reduction. We looked at that towards the end of the 5.1 process and realized that nobody could understand what, even on the language committee, could understand why it was defined the way it is. And the result that it provided was very strange. Basically, it was called the minus reduction, but you got a sum reduction. So we decided that should just be removed. So it will be deprecated in 5.2 and removed in 6.0. We also have deprecated some aspects of the syntax of the linear clause because it was a complete one-off. The reasons for are kind of down in the weeds, but it will now be much more consistent with the way other clauses are the syntax of other clauses. Another one that we're changing the syntax for is the uses allocators clause on the target construct. That was extremely strange, complete one-off on its, and a poll of implementers led us to believe that nobody had yet implemented it, and everyone would have found it difficult to implement as it had been specified. So we made it again much more consistent with how other clauses, the syntax of other clauses, and we believe it'll actually be easier for users to understand what it's doing as well. Let's see. So we're deprecating the limited form of the declare target directive. We had a few versions ago adopted the begin declare target directive, which basically replaced the declare target directive, but we just failed to deprecate that form of the declare target directive at the time. And so we're doing that now because, again, it makes it removes a bunch of ambiguities in the way the specification works. One of the biggest ones that we're changing is actually the depend clause. I wonder how many people are aware that OpenMP supports do across parallelism. We adopted that some time ago. I think it was in 3.1, OpenMP 3.1, I believe. I have to go back and look, but it was many years ago that we adopted support for do across parallelism. Personally, I've been disappointed in the quality of the implementations of it. In most cases, the best implementation would involve loop skewing, and the directive, the clause and the order directive that it works with were formulated in such a way to provide all the information that an implementation needs to know to do the appropriate loop skewing. We're changing that so that now when you want to specify these do across cross iteration dependencies, you'll use a do across clause. The rest of the syntax is basically the same, but now you're formally saying, I want to do a cross-parallelism. And we're hopeful that this will motivate better implementations. All right, so the rest of the changes are kind of down in the weeds of how we maintain the specification. We're going to be generating a lot of the specification automatically. Our intent is that this will improve the consistency of what we specify, and therefore make the language itself better, because either implementers would end up saying, well, we know what the intent was, so we'll implement that, or else they'd have to implement something that was a little bit one-off because, well, we didn't remember to repeat a restriction in this section. The labels aren't the same, so you don't get all the cross-references quite right. The index entries aren't right. We're trying to generally just further improve the quality of the specification. In a way, 5.2 could be viewed as one very large quality control pass. All right, so as I say in this last bullet, we actually expect to then eventually, hopefully for 5.2, for the quick reference guides, we'll see if that works out, actually support automatic generation from what's used in the spec itself to generate the quick reference guide. For the 6.0 timeframe, we're looking at generating a grammar automatically that can be used by implementers to be sure that they're getting the correct parser. On to the next slide, Michael, please. All right, so what are we looking at for OpenMP 6.0? So I've already hinted at this. We started deprecating features in 5.0. It was something that was probably a long time in coming, but we just hadn't convinced ourselves that it was the right thing to do for anything. So we were kind of slowly accreting things that we felt were broken, and we would tell people, don't use that. It's not the right way to do it. Do it this way instead. But the spec still said you could do it the other way. And the reason was, well, we need to maintain that for backward compatibility, which, there's value in backwards compatibility, but when it makes people use features that are not the best designed ones, it's maybe not the end all. The implementers have generally all told us that even if we remove features, they'll continue to support them. Our hope is that by removing them and making them so we can say that's not something you should, it's really not something that exists. Yeah, you can go and still use it because implementation support it. You won't get updates to the capabilities that way because we're not going to update them, and you'll be dependent on implementation defined behaviors for things related to new features at that point. Anyway, so a big thing I think that's increased adoption of OpenMP has been the device support that was first adopted in OpenMP 4.0, and we've improved significantly in each of the subsequent releases of OpenMP 4.5, OpenMP 5.0, and OpenMP 5.1. I think many have felt that 5.0 is where the device support really reached a sufficiently integrated level with the rest of the specification to be really quite compelling to use. One thing that we haven't done is provide true support for using multiple devices. Right now, you can use multiple devices by specifying a device number, but you can't do things like easily update memory across different target devices. You can't multicast data from the host to those multiple target devices. You can't share, you can't work share regions across multiple devices. Basically, anything you want to do using multiple devices, you have to do in singular fashion, so you don't get bulk launch across multiple devices. And you then have to hand implement any kind of sharing of different, of sharing one unified workload. So if you wanted to distribute a single loop across multiple devices, you have to actually do that all by hand. We're definitely also looking at improvements for single device support. A big one that we're considering is deep further enhancements to deep copy support. We added initial deep copy support with user-defined mappers, with the more intricate deep copy support where you can specify serialized and deserialized functions. You would have much greater capability, and in fact, it would actually allow you to map from one type to another, from the enclosing region to what you're actually executing on the device. This could allow you to do things like use a dense structure in your offload region or a sparse structure in the rest of your code. As long as you're copying data from the host memory to the device memory, why not do it compactly? Would be the idea. We're also considering other ways to support memory affinity and complex memory hierarchies that are becoming more and more prevalent in today's architectures. Another thing that we've talked about for a long time is improvements to tasking support. So with task only or free agent threads, this means that you wouldn't have to create a parallel region in order to get parallelism with your OpenMP tasking. Another thing that we're looking to be able to do is for one team to spawn a task that's executed by a different team. This provides a lot of different possibilities that you can support with the OpenMP tasking model. One thing that it particularly would support is event-driven parallelism. So you could have kind of a loop that is your event loop, and when an event happens, either from mousing or from network network messages or whatever the events are, you can then spawn a task that's executed by a different team of threads, which would mean that you could isolate the work for processing the event from the event loop itself, ensuring that the event loop will continue to be responsive. We'll be looking at ways to provide better support for being descriptive in saying, well, here's what I know about the semantics of my code. Compiler, take that and use that to give me better code without me having to tell you exactly what to do. On the other hand, we're looking to provide more prescriptive control as well, ways to say, look, I really want to do this. So one thing that I'm hoping we might do is provide a way that you can say, compiler, I want you to SIMDize this region. And no, I don't care what you think is best. Another thing that we've begun considering as we see a number of data flow architectures and CGRAs becoming popular is support for pipelining and other types of parallelism. Anyway, so with that, I'm going to hand it back to Michael.
All right, so I'm going to inject a quick commercial break, if you will. So if you want to have access to the OpenMP specification, we've been publishing it for pretty much the beginning of time as a PDF through openmp.org. And with, I think it was OpenMP 4, we also started publishing the OpenMP specification as an HTML document. which greatly simplifies, referring to it from the internet. So, the PDF is still kind of the ground truth of the OpenMP specification, but the HTML makes it more accessible. And then about 5 years ago, we also started publishing the OpenMP specification as a book. So if you like the look and feel of a real book on your desk, you can now get that through Amazon. We pretty much sell that at near wholesale price, so pretty much at the cost that we incur for the on-demand publishing of the book. And that's a great way to show your OpenMP Pride in your bookshelf. And as promised earlier, I wanted to come back to our members. And one of the things that the ARB is having as an invaluable resource is the members that support us, that contribute to the OpenMP specification, that hand in proposals, and that put in all sorts of resources to help us develop the OpenMP language. This is just logos. If you read through it, it's the who's who of HPC. There's almost all major HPC vendors are on it. All major users of OpenMP are on that. So especially from the Department of Energy, the national labs in the US, but also some tier 0 centers from Europe are there, and other companies who have a vested interest in developing implementations of OpenMP or are OpenMP users. And you can consider this webinar as kind of a call for participation. So if you are interested in joining the OpenMP ARB, one thing that we did in the past years was make it easier to become a member. And what we did is we introduced 3 membership classes with different price tags. So that you can pick and choose what is the best for your organization and the level of contributions that you would like to make. I don't want to go too deep in this, but pretty much, you can start at ARB contributor if you just have an interest, if you want to get access to the technical information and the drafts that we're working on, and you will get some initial voting rights, and then ARB advisor, that's kind of the next level where you have more ways to contribute, and then the highest membership class is ARB member, where you also get to vote on organizational topics in addition to the technical topics. So you pretty much then have a say in the strategy and the direction of the ARB itself. The way we interact with the community is through several events. Again, if you want to know more about this, visit openmp.org. There's the OpenMPCon Users Conference. That is a gathering of our community to just discuss what they're doing with OpenMP, raise questions, and interact with the ARB. Then there's the International Workshop on OpenMP, or IWAMP. That is the research venue of the OpenMP ARB and the community, where people can publish latest and greatest research that involves OpenMP and parallelism in form of new OpenMP proposals, but also how OpenMP is used in HPC applications or beyond HPC in other domains as well, and how OpenMP is used in reality. And these 2 events are kind of the prime venues for us, the ARB, to engage with our community and talk to them, get their feedback, and also draw proposals from it. Then there's a special event in the UK. The OpenMP users group there runs a yearly meeting. This year's actually a joint meeting between OpenMPCon and the OpenMP users group of UK. That's another event where there's a good share of OpenMP ARB members available to discuss proposals, give feedback on OpenMP, and for us to interact with the community. And naturally, you know, supercomputing and international supercomputing, these are the two major conferences in the HPC and supercomputing space. And we usually have a lineup of several tutorials that teach different aspects of OpenMP to our community. So for this year's ISC, we do have a tutorial called The Common Core, where the community gets to learn how to, you know, be introduced to OpenMP. And then there's Mastering Tasking with OpenMP, where people can learn about modern OpenMP tasking. And for this year's supercomputing, we're also submitting, I believe, on the order of 5 or 6 proposals for tutorials to also teach the community how to do OpenMP programming. If you want to learn more, just visit our website, openmp.org. There you can find the specification, links to webinar videos, training videos, recorded tutorials, blogs, upcoming events. So pretty much this is the one-stop shop for you if you're interested in OpenMP. All right, and there is a question. What's the status of OpenMP, of Compunity and its role in the ARB? So Compunity initially was, I would call it a meta member, where when we didn't have the refined membership structure to make the ARB more accessible for new members, Compunity was a way for people who published at IWAMP to go into the ARB as part of the Compunity membership. I would like to move Compunity to be more of a user group in the future. So to take care of the community and be the central place for the community to interact and you know, organize events and that kind of stuff. So they are still a member in the ARB, but I would like to take them to be more active in the community as kind of the ARB's community branch. All right.
So Michael, would you
ahead,
say
Chris.
it's fair that Compunity membership can serve as kind of a way to get an introduction to the workings of the language committee and the technical aspects of the OpenMP community, the OpenMP ARB, but you know, as you become more and more, you know, if you find that you're deeply involved in it, then we would probably encourage you to become you know, particularly if your organization has many people participating, we would encourage you to have your organization join.
That's right. Okay, let me close. So to summarize what you heard from us today, so 5.1 and 5.0 were a major leap forward for OpenMP, where as Bronis and I explained, we introduced big features to OpenMP that made OpenMP useful in this heterogeneous system architecture that we're seeing in the community today. We also explained that OpenMP 5.2 will improve the quality of the specification. We will clean up a bit of baggage that we accumulated in the past 2 decades and bring OpenMP in shape for the exascale era. And then OpenMP version 6 will then add new significant features that Bronis already kind of mentioned. And if you have particular feedback on which directions we should be going, then we would be happy to hear that either in the Q&A session coming up or offline via email or any other mechanism how you can interact with us. And then hopefully you can now see that OpenMP is a modern programming model. We adopted the best practices of the community. So we now have this multi-level parallelism supported, consisting of coprocessors or GPUs, if you will, threads and SIMD. we have a very modern and expressive task-based programming model with dependencies and built-in interaction with the offloading to GPUs and coprocessors. We do believe that we have a powerful language that lets you express complex algorithms. And we still have this span from high-level access to parallelism, but we also provide a path forward to highly efficient programming through the prescriptive mechanisms that we have in OpenMP. And with that, I'm done. Bronis, final word?
You caught me by surprise there. I'm ready to answer questions. Stick it through. We have a couple questions, and then hopefully we'll get some others. And we also had a poll that we're conducting.
All right.
Why don't we go
Yes.
ahead
With that, I'll hand back to Lizzie for the poll. Yes, Lizzie, you're up.
All right.
So Lizzie,
you should all see the poll results right now.
Shockingly, I'm surprised it's less than half find all of the restrictions confusing. I'm not surprised most people have no idea what composite constructs are. All right, well, we'll come back to the poll results in a second. First, let me handle start and answer for Jose's question. Are you aware of compilers that will fully implement 5.1, given that 5.2 is coming up this year? Are users encouraged to ignore, in scary quotes, 5.1 once 5.2 is released? So I'm not an implementer. I did notice that we have a couple of implementers on the participating. So I see Jeff Sandoval, I see Jenny George, I see Johannes Dorfert. So take anything I say about what implementations will do with a grain of salt. I know that many of the implementations are very actively working on implementing 5.0 and are getting close to having 5.0 fully supported. I personally am paying particularly close attention to the HPE and AMD implementations these days, because I'm worrying about what we're going to end up citing when we cite the El Capitan system that we're in the middle of procuring from HPE. And I know that HPE has made a lot of progress on 5.0. I know we've already begun working with them on assessing priorities for 5.1. I think they've even begun a little bit of work on implementing 5.1. If I were to guess, it will vary by the implementation, and some will be more sequential about it for whatever reasons, whether they're contractual or just they've already started on 5.1. It's easier to finish than to just change horses in midstream. But in general, my encouragement to users is to look at the latest version of the specification and tell implementers if they don't support, if there's something in that they don't support that would be useful to them, tell them it would be useful and get them to support it as soon as it's useful. I think the latest version of the specification is always the best version.
Okay, there's another question that I would like to take. Can you tell a little bit more about tasking support improvements in OpenMP 6.0? So with OpenMP 4.0, I believe it was, we introduced task dependencies Then with OpenMP 4.5, we started introducing the task loop construct, and we kept refining it. And so one of the big improvements that we're planning for OpenMP 6 is to unify all tasking features to support dependencies so that you can synchronize tasks that are coming from a task loop, irregular tasks, and offload tasks using that single model. And then Braun has already alluded to it about free agent threads, or I think one working title was unshackled threads, where you could pick threads out of your available threads and use them to execute tasks outside the regular work sharing. So that should give us a way to make it easier to get parallelism with tasking, and refine the way task execution is happening in the system.
I'll just note that with deprecation of the master construct in 5.1, the term unshackled threads is no longer appropriate.
Okay.
All right, so we have one more question, and I will try and answer that. What is and will be the major differences between OpenMP and OpenACC? Well, you're asking somebody who's biased on this question, so you can take what I say with a grain of salt. I know what the OpenACC proponents claim, most of which I think is frankly hooey. You can do what you want with that. The reality is OpenMP is a complete specification. It provides features that are appropriate regardless of the type of system that you're using. And it provides capabilities to let the compiler know that you're restricting what you're using in such a way that it can make optimizations for a given type of device, whereas OpenACC really only supports GPUs. And when you try and use it on the host, it does not have a sufficient feature set in order to allow you to parallelize a large amount of code that can be parallelized efficiently with OpenMP. So early in OpenACC's lifetime, we had the OpenACC proponents telling OpenMP that we needed to provide support for interoperability with OpenACC, which was just ridiculous, since given at the time they were making those statements, we already had support for devices. They had nothing in OpenACC that you couldn't do in OpenMP. And so that's the difference. You can do a lot more with OpenMP than you can with OpenACC. Let's see. OpenMP affinity and binding is rich and well defined, but does MPI have any now standard binding option to make we know who is driving the bus? This is a continuing source of confusion and complexity. Well, so I'm sorry if the interoperation between the two, between OpenMP and between OpenMP and MPI is sometimes confusing. While we have many people who participate in both the MPI forum and the OpenMP language committee, they are distinct specifications. So what we try and do is define mechanisms that support interoperability between them, but we can't require anything of MPI by OpenMP. We can't tell MPI, you will do this. We think that with good resource management support, you should actually get good work on binding options. All right, but basically a good resource manager will limit your MPI process in which your OpenMP threads are running to a subset of the resources on the node. I see Johannes has asked a question, but I wanted to kind of quickly take a look at the poll results. So the first question was, we asked that because, frankly, we think that the 5.2 will improve the way restrictions are specified. I'm surprised that a smaller number of people find the way they're currently specified to be confusing. I asked about combined and composite constructs. Composite constructs, you probably think are combined constructs, except that you can't actually specify the one construct nested inside of the other. So, or it's really, what we found is that all of the composite constructs are loop associated constructs that end up associating a single loop nest with multiple loop associated constructs. So distribute parallel for example. All right. And they actually then end up specifying that you first apply the distribute semantics and then the work sharing loop semantics. All right. The way they're specified in 5.1 and before that is just basically we list here's the concatenation of those names, and it means just what you would think. All right. In 5.2, we're going to specify the rules for concatenating names. In 6.0, I hope that we will make the algorithm for determining what names you can concatenate much simpler, because right now it's basically just a big switch statement. In 6.0, the hope is to make it, if you can nest them, you can combine them. All right. So now, Michael, do you want to handle any of the questions that we have out there?
I guess you had already handled the composite versus combined constructs. Johannes is asking about LLVM allows to do remote offloading, so use your neighboring GPU, but there's a lot of features missing in the standard for distributed computing. Will we see more of that in the future? And the way I would like to answer that is that Bronis and I kind of already said that there will be more of this coming, in the sense that we will have more features, how you can deal with multiple GPUs in your system. So that is kind of basic support for that. But we don't have a direction where we want to be doing offloading out of the node and pretty much replace the capabilities of MPI with OpenMP. That's nothing that we have on our roadmap.
So I would throw something in a little bit different there. I see that the #1 priority in terms of responses is 2/3 of you selected enhancements for using multiple devices. And I would suggest that the enhancements for multiple devices would go in the direction that Johannes is asking about, because it would do things like providing the ability to do broadcast across multiple devices. I expect that we would add support for, if you wanted to use OpenMP more like MPI, the first thing that you would need to do in order for it to be a scalable solution is have support for what I call bulk launch. All right, so being able to engage a multiple nodes with a single command, all right, with a single directive. All right, right now, if you want to offload to multiple devices, you have to do a loop over the device numbers. Enhancements for using multiple devices would provide you a way to offload to all of the devices. What you do in there will depend on what we add You could just have launched this target region on this set of devices, and then based on the device number, you might choose to do something. It's kind of like the most basic support for NPMD kind of programming. But we'll probably also have ability to partition loops across multiple devices, for example. All right, well, we're at the bottom of the hour. I think we've answered all the questions. We can be available a little longer if people would like, or you know, type in another question if you want, if there's something else you'd like us to discuss. All
right. Well, thank you, Michael and Bronis, for that excellent update on OpenMP. It sounds like there's exciting things ahead. Thank you all for your time today. We hope you enjoyed the webinar. A recording of this presentation along with the slides will be available on the OpenMP website. A direct link will be sent to you in a follow-up email. Also, as you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to help us improve these presentations. So please let us know if there are other OpenMP related topics you may be interested in. Feel free to keep adding questions if you'd like. Otherwise, we hope you have a great day. Thanks, everyone.
Thank you.